Let's talk about one of the weirdest things in AI right now. How can a machine that has access to basically all of human knowledge be so forgetful? It's a huge puzzle, and we're going to dive into how we're trying to solve it, how to give a genius a memory. I mean, it's a wild paradox, isn't it? These incredible AI models can write a sonnet, find a bug in your code, explain quantum physics, but without some clever tricks, they have no idea what you said to them 30 seconds ago. So, what is actually going on? Well, it all comes down to one core concept. These models are stateless. Just think of it like talking to someone with total short-term memory loss. Every single message you send, every prompt, it's like the AI is meeting you for the very first time. The only reason it seems to remember your conversation is because the app is secretly stuffing the entire chat history into the prompt every single time. It's a smart workaround for sure, but it's not real memory. So to fix this, researchers have kind of split into two main camps. The first philosophy is pretty straightforward. You could call it the bigger brain approach. The idea is simple. If the AI's working memory is the problem, well, let's just make it ridiculously, colossally bigger. But for years, this was basically impossible. There was a huge roadblock, a major bottleneck baked right into the core architecture of these AIs that made bigger memories exponentially more expensive and just way too slow. And this is the engineering magic that changed everything. The old way had what's called quadratic complexity, and it was a total nightmare. If you wanted to double the memory size, the compute cost didn't just double, it quadrupled. It was completely unsustainable. But then, new techniques got us to linear complexity. Now, doubling the memory only doubles the cost. This one shift, this one breakthrough, is what blew the doors wide open for AI memory. And when I say wide open, I mean wide open. We are now living in the era of models with context windows, that's their working memory, of over 1 million tokens. Just to put that into perspective, that's like handing the AI the entire Lord of the Rings trilogy, dropping it in the chat and saying, okay, let's talk about it. This massive memory just completely changes the game. All of a sudden, you can analyze a 100-page legal contract in one shot. You can have it understand an entire software project to find bugs, or you can feed it thousands of examples of a new task to teach it a new skill, right there, on the fly. But that's just one side of the story. There's a whole other school of thought. Instead of trying to cram everything into the AI's short-term memory, the external notebook approach says, let's give the AI a library and just teach it how to look things up. And the technology that makes this happen is called Retrieval-Augmented Generation, or RAG for short. The idea is brilliant in its simplicity. You just connect the AI to a database. It could be your company's internal documents, medical research, anything. And when you ask a question, the AI first does a quick search, grabs the most relevant facts, and then uses those facts to write its answer. The whole process is really just a three-step dance. First, you index all your knowledge, basically turning it into a smart, searchable library. Then, when a question comes in, the retrieval step acts like a super-fast librarian, instantly finding the exact pages that are most relevant. And finally, in the generation step, the AI takes those pages, its little cheat sheet, and crafts a perfect, fact-based answer. So why would you go through all this trouble? Well, the advantages are massive. For one, you can update the knowledge base in real time, something that's impossible with a pre-trained model. It also dramatically cuts down on the AI just making stuff up, what we call hallucinations, because it's grounded in actual facts. And this is a big one, it can tell you exactly where it got its information. It can cite its sources. Okay, so we have two really powerful solutions here, the bigger brain and the external notebook. But here's the catch. Neither one is a silver bullet. In fact, both of them have a potentially fatal flaw, so let's put them head to head. This quote from a really important research paper points to the shocking weakness of the bigger brain approach. Even with a memory that can hold 1 million tokens, these models have a very human-like problem. They're great at remembering the first thing you told them, and they're great at remembering the last thing. But all that stuff in the middle, yeah, it kind of gets lost. And you can see it right here in the data. Researchers call it the lost-in-the-middle problem. They basically hid a key piece of information at different points in a huge document. And look at this U-shaped curve. If the info is at the beginning or the very end, recall is almost perfect. But when that same fact is buried deep in the middle, performance just falls off a cliff. It's almost like the AI's attention just wanders off. Okay, so what about the external notebook? It has a totally different problem, but one that's just as critical. The entire RAG system, the whole thing hinges on that one retrieval step being perfect. So What happens if the librarian pulls the wrong book from the shelf? So let's just lay it all out. The bigger brain is super fast and can see the big picture in a static chunk of data, but it literally gets lost in the middle of its own memory. The external notebook can tap into this massive, always current library, but if its retrieval system messes up and grabs the wrong document, the whole process fails. Garbage in, garbage out.
So this is where it all gets really, really interesting, because the future of AI memory isn't about one of these approaches winning. It's about a clever, powerful alliance between these two rivals.
And the solution, it turns out, is an idea that we've been using for decades in every single computer we own. It's called a memory hierarchy. Let me break down the analogy. The AI's huge context window, its working memory, that becomes its cache. This is super fast, immediate memory for whatever it's working on right now. Then, the external RAG database becomes its hard drive, a vast long-term storage space for, well, everything else. This hybrid model gives the AI lightning-fast recall and access to a comprehensive, up-to-date library. You really get the best of both worlds. And this is why all of this matters so much, because solving the memory problem isn't just about building a slightly better chatbot. It's laying the foundation for the next great frontier in artificial intelligence. The ultimate goal here, the real vision, is to use this kind of persistent memory to fundamentally change what an AI is. We want to go from a static tool that was trained once and then frozen in time to a dynamic agent that can actually learn and evolve from every single interaction it has. Its own memory becomes the raw material for its continuous self-improvement. Which, of course, leaves us with one last really big question. An AI that can't remember is, at the end of the day, just a very sophisticated tool. But an AI that can remember everything, reflect on its own experiences, and learn from its own unique history, what does that become? That's the question we're all waiting to see answered.